string to safely anchor in the land of forever love. The figure 8 knot, the square knot, and the wedlock knot. Both, yes. Ben's has over 2,000 wedlock knot wedding band designs to try on, pair up, and have made to order to fit those perfect little things.
Oh, very clever.
So secure your love with a wedlock knot wedding band from Ben.
Hook, line, and sinker.
Ben's Diamond. I do! Find us in Vaughan, Scarborough, and Mississauga.
Hey, it's your fourth vehicle here. Tough year, I know. But summer's here. Time for us to hit the road. But I could use a little Ford service time first. You know, some extra hands going over my body, checking under the hood. $99.95, including oil and filter change, vehicle report card, 83-point inspection, and tire rotation. At Ford Service, we remark gowns. This is a live taxes extra. Book your appointment today at report.ca.
Hi, I'm Kate, the team member here at New World, where we help clients save money. The truth is, most home loans don't work because they're expensive. At New World, we focus on buying the home loan, so we use a different approach and plan ahead. We show you the best options, help improve your credit score, and make sure you save money. Unlock the equity in your home today. Use your home to get a loan with New World.
Visit newborrow.com, license 13115.
With the daily grand lotto, you could win $1,000 a day for life.
Wait, every single day?
Yeah.
So
Everybody hates Mondays, so I suddenly be an outcast, living on the fringes of society, a bizarre Monday-loving weirdo.
But you get $1,000.
Well, welcome to my shop. Thanks for joining me here. It's July 12th. It's been actually a few days since I've worked on this radio. I got way ahead on video segments, and so I've just been posting videos the last couple of days and spending my time outside. But now I'm back in here. I thought I would start off with a really good listening test, and I gotta make a determination whether I want to go further with this or not. I'm beating my head against the wall, something terrible. So I'm not so sure what I should try doing to make this radio work better. I'm pretty much at the end of my rope here, in fact. But there is a component in there I'm not terribly familiar with, a Varister, and it's right involved in the audio circuits. And so I'm curious about it. I'd like to know a little more about the Varister. It's hard to see. It's tucked down under this transistor here. It's very hard to see. On the schematic, it's shown as a diode Varister. Interesting. So I'm going to read up a little bit on varistors and why is it in this circuit? What's it doing? And could it be the cause of all these, the cause of the distortion that annoys me so much? Good question. Well, I think the best place to start is right here with the schematic. So here it is here. You know, when I first saw this on the schematic, D2 diode number 2. That's what I figured that is. But in the listing here, so D1 is a diodo, and D2 is a varistors, plural. IT51, IT23G, IT51. Well, I'm going to hunt down on the internet what this is. I mean, varistor sounds like variable resistor, doesn't it? I'm pretty sure that's the effect it has, but how it operates and why is it here is a good question. Well, that doesn't help the situation any. A varistor is, of course, a variable resistor, a voltage dependent resistor, if you like. They're made in a couple of different ways. Some of them are made with a piece of semiconducting material inside, a little like a diode in a way, and that's probably why the one in this radio is called or is denoted as a diode. The varistor, we should really look at the schematic here. Okay, the varistor is sitting here. Its characteristic is its resistance varies with the voltage pressure on it. I'm going to guess that the purpose of this is to compensate for the battery supply weakening. So you're going to start out with 3 new batteries. You're going to get 4.5 volts here, but at some point the voltage here is going to drop low enough that it's going to start exposing any of these transistors to I'll call it clipping. It's insufficient voltage supply for them to operate with the range they're trying to operate through. And this, of course, would be most likely occurring with these transistors. So, in other words, as the batteries wear down, unless something is done, these transistors are going to start operating improperly. So what's done is this variable resistor is put here. I wonder if it's comparable in resistance to this resistor, R19. I wonder if that's the case. R19, 220 ohms. I don't know the resistance of this. So there is a current flow through the winding here and through these transistors and down. The current would come down through here. The only current that would flow here would be current flowing through the diode. All I can assume is that this is what it is. It's a bias controlling device. Really let you drain the batteries on this radio. It's really what the idea is. Now, what if it's not working? Well, how can it not work? Like, what can happen to it? I guess it go open, go shorted. The resistance could float high, sink low, fail to vary with the input voltage. I guess all those things are possible. Well, if it were open circuit, for all I know, the resistance of it under normal circumstances is very, very high in the first place. I really don't know. I tried looking this thing up on the internet. Let me show you something here. Look at this. Here it is. Okay, that says IT51. Now look at this. 1T23. So is this an I, or is this supposed to be a 1 here and they made a mistake? When I type in IT51, I get all kinds of weird stuff, nothing to do with electronics. Now 1T51, I get a couple things. I get one hit. I can't find any reference to a 1T51 varistor in my researching anyway. So I haven't got any information other than general information about varistors. And in fact, some are made with semiconductive material in it. This one probably is, and others aren't. The typical purpose of a varistor is to prevent voltage excursions. So you put it in parallel with something, and if the voltage supply shoots high, the varistor will take it on the chin. Its resistance will appear low, and it'll draw the current and pull the voltage back down. Pull the voltage back down. Wow. If D2 is wide open, then the voltage drop on R, let's see, what would happen? What exactly would happen? So if we just, in my imagination, change D2 to a resistor. So you got the two resistors there. It's a voltage divider, setting the bias voltage for the two output transistors. See, I wonder if I can figure out what that output, what that bias voltage ideally should be, measure it, and deduce that D2 is open. Now, if D2 shorts, it's not the end of the world either. R19 is sitting there. Yeah. Well, things just wouldn't be right. Now, they haven't been kind enough to put any voltages on this diagram. Well, I guess collecting more information around here, I get the voltages from those different points here around the two transistors. So, what's the voltage here, most importantly? But I don't know what it should be, because I don't know what this value normally is. Just swimming around in so many unknowns here. Wow. Well, let's get some voltage numbers out. Anyway. Okay, now with this radio, similar to the last few I've worked on, it has a volume control which just will not go to 0. It's kind of a poor way to turn it down, but at least it wants to work. Oh, you turn it down with this too. There we are. You know, when you listen to it like this, let me just be quiet for a minute. Just listen very carefully. I think I'm hearing the sounds of something running in a cutoff type situation. The spiky little ticky sounds. And his voice is extremely buzzy now. So if I were to determine the Varister was bad, what would I do? I don't. Well, I have lots of Varistors, but they're great big things. They're great big guys. They're not little puny tiny things like that. I suppose if its purpose is to compensate for dropping battery voltage, you could get rid of it, get rid of the compensation, put in a resistor of the appropriate value, and just put up with not being able to drain the batteries all the way down before you get a sound like this, maybe. How can we temporarily test it? Voltage readings. That's what I was going to do. Voltage readings. I'm going to scare the radio with this old tube meter here. Okay, DC plus. Let's check our input voltage here. 3.5. So we want to go a little higher. We don't want to be down there. That's too low. I'm going to make these voltage measurements. Volume up. 4.5. That's the correct voltage. Okay, I can get one end of the Varister lead here. Right over. Okay, other end of it. Well, maybe. Right over. 4.5 exactly on that meter. 4.5 exactly on. So both sides have exactly the same voltage on it. Then there was the 220 resistor. I don't see a 220 in there. Except this one. I thought this was something else. This is one side of the resistor, other side. Tiny reading there. Nothing there. Oh, there's that sound. It's kind of a bloop sound. Should be, if I measure the base here or the base here, I should be getting pretty much the voltage here. So a small DC resistance in these, in here. So that should give me the far side of this. Give me the bias. What is the bias on these two transistors now? Which leads are the base? Those are B48, SONY B48 transistors. Okay. Okay, base is the middle lead. There's one. Really? And the other one. What made that noise? Okay, middle of the other one. What's this? That's all it is. Just a loose connection there. Okay. Solve that one. Well, that doesn't seem right. What else we got on these transistors? Huh. Okay. That's not good. Yeah, that's not good at all. The base and the okay, that yeah. I'm a little beside myself because there's something dramatic appears to me to be dramatically wrong there. Just when I think I'm getting a grip on things, oh no, let's go through this. So here's the two output transistors, X6 and X7 written right there. X6 and X7, T28, 2T8 or 2T6, but that's not what's in there. That is not what's in there. What's in there, we will take a look now. The situation's become a lot more complicated just in the last few minutes. See if I can uncomplicate it. That pretty clearly is a SONY B48. Okay, SONY B48. Let's look at that on the internet. Okay, here we are at the B48. Okay, germanium PNP transistor. There we are. There's the layout of the parts, and there's a little tab. There is a tab on the can you can spot. So you can figure out emitter-based collector that way. That's great. Here's the symbol. If you notice, the arrow here is pointing in. It's pointing in. PNP. Pointing in. Now, let's look at the schematic here. PNP pointing in. NPN pointing out. So this is covering is probably matches these. But that's not what's in this radio. So, how much different is all this from the schematic? Have I got like a later version of this radio, and this is an earlier schematic? And that's a dramatic change to go from NPN to PNP, or vice versa. I think that's a dramatic change. That's a significant change. Can you even do it? Or are those transistors that I've got in this radio the wrong transistors? Oh my gosh. Is it possible somebody changed them? No. I think this radio's been in the possession of the family who owns it since the day it was bought in the store. And I don't think any of them have been in here changing transistors. So the only possible answer is the radio I've got doesn't actually follow this schematic exactly. At this point, something different is going on. No. Yeah, let's leave it at that. I'm going to mark up a sheet with the voltage measurements and we'll look at it then. This is really forcing me back to my college days here. So what we've got, here's the two transistors shown pictorially, physically the way they are arranged on the circuit board, like this. Orientation is the same. Marked a little tab, shows me where the emitter is, emitter base collector. They're both in exactly the same way, emitter base collector. And I've written down the voltages here, 4.5. It's pretty easy, 4.5 and 0. So emitters 4.5, base 4.5, collectors 0. Why would the collectors be 0? So if we take this circuit, I realize this top physical transistor that's sitting in here, the top lead is the collector, and the top lead has 0 volts. So we know it's the collector, assuming the circuit is basically the same, except something's going on with the different transistors. The collector's here, and the collector, follow it through here, follow it through here, and we are connected to there. Wait a minute, that's not what I was expecting. Likewise down here, this collector, DC wise, to the supply. Emitter through a couple small resistors down to the other side of the supply. And the base, of course, controlling what's going through the transistor. But the base is fixed at 4.5 volts. How do we get that? How do you get 4.5 volts there? Open circuit on this. If we have an open circuit here, then the voltage at this point is going to rise up to here, except for the small voltage drop on the 220, based on the current flow through the transistors, which is bound to be quite low. The base current is going to be low. So you're not going to have much of a voltage drop here. The conclusion of this situation would be the diode is shot, the Varister. What the heck am I going to do about that? I mean, I don't have. Apparently, nobody has one of those. It doesn't even the internet doesn't have one of those. So if my thinking is right, it's really a battery control. For battery weakens, it kind of helps keep the bias voltage where it should be, I guess, relative to the. You think the whole thing would go down, together, like all these voltages are dropping together, so their relative, their relationship would remain the same. But I don't know. This guy. So what do we do with this guy? If he's open circuit, because I measured 4.5 volts right here, also. Of course, 4.5, 4.5, 4. It's the same piece of wire. So So I have lots of varistors, but they're wildly different from this little tiny guy, which you can hardly see. Let's take a look. Let's take a look at it. Maybe there's something different about the varistor from the circuit diagram too. Maybe there's more difference than similarity. It's really hidden down under that transistor. There he is. Kind of an odd spot to put it too. Can we read a value on it? Because if the transistors are different, this varistor is probably different also. Well, we're going to have to blast it with a lot of light to get a look at that. If there's any writing on it. Let me get the camera fixed here in place. Hold still. Okay, it's not exactly dead center, but let me fix the focus here, see if we can get a little sharper image. Okay, and now bring on the floodlight. Not focused. I don't see any writing on it. Let's see if I can just pull this back a wee bit. I see no writing on it. Definitely looks like a varistor though. It has the look of a varistor. The leads are coming up either side of a wafer. Any chance? No chance of seeing anything underneath there in terms of words. Ay. So, yay. Yay. I can't find any information about the varistor that's supposed to be in there. So I don't know what its ratings are. So how do you replace something you don't know its ratings? I don't know if I have something like that. I have not exactly got a declared box of varistors. Or do I? No, I should go take a look. Well, here's my meager supply here of varistors. Yeah. One that's in there is tiny compared to these. This one says 6 kV on it. Probably out of a TV set. An old TV set with the high voltage for the picture. Picture 2. 125 volts AC, 0.01. I don't know. Is it? Maybe this isn't a varistor. Maybe this is a... I have no idea. I'm not going to get anywhere with this. The name of the game here will be to understand what the varistor is doing in the circuit and what alternative I can use. You know, what alternative component or just drop it entirely. Put a resistor in there. That's got to be what happens. We're looking at the schematic here. Both bases are getting the same voltage. We have no idea how it would divide between here and here. Base voltage for B48. It must be on the sheet here. Quick, let's take a look. UCB, that's probably the maximum NA1. Okay, this didn't help me one bit here. This didn't. I'm looking for something that says, yeah, it's not probably going to show a voltage as such. You know, these are current devices, right? So I could put some kind of variable resistor in there, manually variable resistor temporarily, vary it, and see what happens. In the worst case right now, it looks like the varistor is wide open. So we have kind of the worst case for base current, I think. We got the maximum pouring through there. Oh man, that's the kind of thing that would burn out a transistor too. So if I nip one leg of the varistor, nothing changes if the varistor is open. And the variable resistor thing, like a temporary one to put in to find the ideal value resistor in there. I mean, we could just guess, just take a guess, but that's kind of corny. And it's in the worst case situation right now. I can only make it better. Can I test the varistor? How do you test a varistor? You put it on this thing. Oh, by the way, one of you sent me a note saying, hey, what is that thing you're using? So here, take a look at it. See, it says MK328. Look at the way it looks. You know, you can find these on eBay. They can find all kinds of these now in the $50 range, something like that. So there it is. Whoever was who asked me that question, there's your answer. This has been a great device for me. I'm almost ashamed to use it. It's so it requires very little brain power. Okay, so we're gonna get the varistor out. I'm gonna read up on how to test a varistor. We're gonna get it out. We're gonna see what happens there. Well, okay. So varistors, you know, are normally used as protective devices. And this would be in modern electronics. You can't call this too modern here. Typically, they're used to prevent a voltage in a circuit from rising above a certain amount due to a surge or a spike or something of that sort. They're pretty good at fast response. What's it doing in here? I think it probably has, it's probably being used like a voltage regulator of a sort, and so it's probably dropping a constant amount of voltage regardless of what it's facing current supply wise. So, and that's a really stupid statement, just ignore that. The real issue here is how do we get, you know, what do we do? What do I do now? Testing it, you would look for it to be open circuit when there's no voltage on it. Kind of the situation here a little bit. They tend, because their duty is protective, they tend towards being burned out under certain bad circumstances. And if they're burned out, the resistance goes infinite. If they're operating properly, the resistance is very, very high until you exceed their rated voltage. So this thing could be operating properly. Well, okay, so it could be in here for a couple of reasons. One is some kind of protection. What they are protecting this radio and that circuit from, I'm not sure. This is a battery operated radio. Now, most electronic devices, when you first turn them on, the voltages and current distribution is a little wonky for the first fraction of a second while things charge up and settle down and all that kind of stuff. Could be it's to protect these transistors the moment of turn on. I would suggest a rise in voltage beyond the capability of the transistors. They need to be protected from. Right now they're sitting there with a full 4.5 volts on the base. There is nothing being protected. And it would appear the varistor is just open. So, you know, this is old now. Perhaps all that's happened is the varistor has lost its varistoring, and that's all that's really happened here. If that's the case, if it's gone open and it's going to stay open, then I'm going to put an ohm meter on, I'm going to read open, or some high resistance. It's not going to help me any. Wow, I'm back to wiring in a variable resistor and experimenting. If it's open and like out of the picture, there's no reason to remove it. It's open, but I have to get a component across that across that really means, what's it really mean? It really means from the center terminal here, well, this is easy. I can pick off that center terminal easily, and I can pick off this ground easily, and I can put a component temporarily in, a variable resistor. This is easy. Let's do this. Let's do this. So it's going to go from the center terminal of the transformer here, right, just from the center terminal to ground, with a variable resistor of how much? So the one up here in the circuit was 220, wasn't it? R19, 220. I'd have to think, if I'm working with something 10 times this size, it'll go from 10 times down to 0. That would certainly cover the range, even doubling or tripling. So like a 500 ohm pot would do it. Okay, gotta see what I can dig up here. So I've been rummaging around trying to find what I need to temporarily and experimentally replace the Varister with a variable resistor. I'm thinking, oh, you know, all these potentiometers are like 10K, million, they're all way beyond that. And it's true. I have lots of different ones, and I've tested many of them. They're all way beyond what I'm looking for, right? Because that resistor is 220, so I'm thinking 1,000 ohm potentiometer would probably be a good start, or anything in that area. But surprising, and I'm thinking you're not going to find potentiometers with low values. Look at this one. This is a 15 ohm. I measured it. It is. It's 15 ohms. This guy is 10. Oh no, this guy's 100 ohms. Now this guy is the big daddy of them all. 5 ohm potentiometer. Wire wound. That's wire wound? I guess so. Yes, I even checked my wire wound resistors. They're all too high. Everything's too high. But I did find this. A paper bag that says VDR, voltage. I want to say VCR. Here's a whole bunch of them. Varistors. This has forced me to look into how these are rated and all that kind of stuff, and how you know, you can get on the internet, you can find a chart. It'll show you these colors, you know, how they work and that. Based on the chart, the lowest you'd ever expect a varistor to have its trigger voltage, if I can call it that, is about 10 volts. Well, there's only 4.5 volts in here to play with. How can I determine what I need to do here? I could try experimenting with these. I just don't think it's going to work out. More thinking. More thinking is required. And hunting. Well, a little more hunting right away turned up these guys. Maybe one of these is going to do the trick for me. Let's see. A lot of number 1.5K. Okay, this is in the ball, brand new. This is in the ballpark for sure. Actually, this is really good. Got one. I got one I can do the test with. These guys usually have fairly low resistance, but it's probably too low. I think we got one we can work with. I think I need to fiddle with this. You hear the wire in there. Okay, so the name of the game now is to set up an experiment in which I replace the varistor with a variable resistor, which we then adjust and see if we can't clear up the sound on this radio. Not terribly hopeful, frankly. Again, because the varistor that's in there appears to be just open, then I'm going to leave it there, and I'm just going to essentially bypass it, or yeah, bypass it would be the right word. With this guy, maybe I can even do it with clip leads. I want to get on the. I want to get onto the base. No, that's easy. I want to get on this negative line. That's the other line. And the negative line, I can pick this up all over the place. Okay, let's just go ahead and do it here. So weather around here yesterday and today is pretty nice, but the forecast is for like 7 days of continuous rain coming. So 7 days of rain, not continuous rain. Okay, so we're going to put this on the inside lead there. Now I need another clip lead. And this one we want to clip to the general ground, which I think is this plate. We'll set this for almost maximum resistance. Should hook up a voltmeter so we can see what's happening. That would be a good idea. So we can just use the this voltmeter right here. Okay, negative still connected. We're connected up here though. And another clip lead. I need to check this. I forgot what I was clipping to. What am I doing? Lost my way here. That to that, that to that. Do I need another? Oh yeah, for the voltmeter. Yeah. We're trying to see the bias voltage, which would be at the end of this green wire here. $5 volts scale. I think that's it. I'm going to turn this a little lower. It's really not going to affect the voltage till you're somewhat past halfway, I would think. Are you ready? What do we get now?
Everybody, if you can get the sound of my voice, and I love you for following me. Thank you so much. Get off with.
Now, is there a chance that if I reduce this to 0, it would damage something? I don't think so.
This is the 5th shooter, and I'm sure he thought he had all the confidence in the world that he was going to make it. A teenager, though, to be in that situation.
I don't know where I am on this, so I'm going to find out where I am. So that would be 0. Oh, I'm not even watching the voltmeter. I have not been watching the voltmeter. I'll turn this up. So 0 is this way. I'll turn it up to there.
In soccer, but I witnessed it in that position. Now, there were still some more experienced players available to them. You know, Ray Sterling, Luke Shaw. There's tough young guys. But perhaps guys who
coming down.
Maybe, but maybe they didn't. Maybe they stood back in the back of the huddle. We don't know, you know.
The radio started humming.
As much as, you know, you criticize
the fingers off
a bit more credit for having the guts to step up in that position, you know. Find that ball and say, give me that ball for the 5th kick, which is generally the most important kick.
Yeah. Okay, last one. Because again, you're so uniquely qualified to answer these questions. You've been over here on this side of the Atlantic Ocean since you were 16 years old. Diehard big fan.
Well, that's the experiment. The result is, as usual, completely unexpected result. Didn't seem to make any difference to the operation of the radio in terms of the distortion I've been listening to, but this hum showed up. Hum? Where's the hum coming from? How can you get a hum? From my power supply? That's a very high quality power supply. I don't believe it has a hum in it. So I don't know what happened there. What happened there? Hum coming from my voltmeter. Is that possible? That's possible. Remember, there's a grounding issue here. And right now I've got this control You know what? I'm going to move the ground from here. Now it's going to be right. The power supply is not grounded. Just reviewing everything quickly in my head here. Should be able to apply this ground right here. Let's turn on. Okay. Voltmeter. Hey, where'd it go? It's going down slightly. Yeah, okay, hum. Where's a hum come from? And that's aside from the point here. My experiment has failed to prove anything. Didn't get anywhere here. Oh my gosh, what a jackpot. Can't figure out the value of the component. Not really sure what it's doing there in the first place. That's the Varister. Don't have one to replace it. Would not be normal, I think, to have a transistor circuit with, like if you look at this transistor, it's got a resistor here and a resistor here to create a, I should say voltage divider, current divider maybe is a better word for it, through here. Same thing, resistor, resistor. If you look at this one, somehow it's, they've done something funny here. Look at this one, oh my god, again, we're not going to find a, here we are, resistor, resistor. So this is kind of a typical arrangement for a transistor. Come over here, the resistor, resistor thing would occur one here and one here. But for some reason you have this crazy diode 2 here. So I have seen diodes used for controlling bias. Sometimes they stack a couple of them in series because it has a very consistent forward voltage drop, 0.7, 0.75, somewhere around there. Very consistent. I gotta find out more about these transistors. There must be more information about them. SONY B48s. Oh boy, oh boy, oh boy. Well, we're kind of getting into the zone of desperation here. So without removing the output transistors, I've connected all the leads here to test one of them. And it's still in the circuit. I have no idea what this is going to do. Make sound in the speaker. So it's identified it as a transistor, sort of. 553 millivolts, 295 millivolts. What I'm looking for in this test, in this situation, is a 0. There's no 0 here. So that sort of suggests these transistors are okay. At least no short showed up on this test. Let's test the other one. I think this test is valid the way it's going. Okay, I got it hooked up. That's the transistor being blown up right now. So get exactly, not exactly, but very, very similar results. So it's telling me, I think it's really telling me these two transistors are not in trouble. Yet the base, when I'm operating, the base has the same voltage as the one of the other terminals. Collector, emitter, can't remember. Same as the collector. No, same as the emitter. Emitter, collector both have the supply voltage on it. I'm sorry, emitter, base both have the supply voltage on it. So that's telling me no drop towards the base. What's that? No current flowing in the base circuit, so no drop on the 220 ohm resistor? Or the current is so low? We're getting lots of volume out of the radio. We're getting too much volume, in fact, out of the radio. So why I lost my train of thought. Yeah, I'm in here too long. Been in here too long. I'm gonna have to give my brain time to. I've done a lot of stuff here. I gotta let all this kind of sink in. Yeah. Sinking. Well, I'm probably going to give a quit for today. You hear that static? And of course now it stops. Something's happened to my audio system here. I don't know what. Something's making noise. Oh boy, really. So whatever's wrong with this radio is beginning to infect my shop generally. You know, I may have reached the end with this radio. I'm going to have a chat with the owner of it and see what they want to do at this point. I just can't... yeah, you're right. Yes, I know. Let's go outside. Okay, well, I got to stop at this point. And, yeah, wow. Yes. Do you want to go outside? Tell me what happened to your collar. You went out with a collar this morning. You have no collar now. What happened to it? And that's the explanation right there. It's in a bush somewhere in our neighbor's yard. Who knows? That's collar number 2. Okay. That's it for today. Son of a gun. Well, after giving it some more thought, yes, I've hit the end of the road with this radio. I just can't see how I'm going to surmount the distortion. Radio works, pick up stations, you can listen to it. It just doesn't sound wonderful or as good as it should sound, I think. So I'm going to turn my attention to cleaning it up and putting it all back together. And we'll see what it sounds like then. Well, it's the next day and the last day for this radio. I've got it all reassembled and cleaned up. That look nice. It looks really nice. Yeah. Excellent. So, let's have a listen here. Now I'm running this on the power supply still, not on batteries. So normally nothing up here to pick up in my shop. So the rumbling sound is just the power connections into the back. What really should be in there is a tube of batteries like this. But unfortunately, all my batteries went dead here when I left them in the radio for 3 days straight with the radio turned on. So we can't run from batteries. But if you had batteries and you took this radio out of my shop, for sure, out of this house, you know, away from all the electrical interference, like any AM radio, it's going to perform way better. This guy's going to pick up lots of stuff. So okay, well, I think that's great. Very happy with the result. No, I'm not actually happy with the result. This particular radio drove me nuts as I tried to solve the small distortion, which is still there, I think.
He only pitched 5 more times over the next 2 years. Is there any historical comparison that you can make? Well, not me and Angela. If there are any comparisons, they are exclusively in the Negro.
We're not going to be able to trick this radio into working in my shop here. But in any case, a nice little Sony transistor radio. So thanks a lot for watching the series, and I'm going to get back to a couple of projects that I had to set aside, wait for parts and things like that. So the next couple of things will be finish ups, hopefully, and then we're on to I don't know what. Who knows? So have a great day.